Hello, welcome all. Myself Kiran. I am from Department of ISP SVC. Today we will learn about heap sort, that is understanding the heap sort and its sorting algorithm. And let us see the outline. Introduction, what is heap sort, how the heap sort works, the algorithm, advantages, use cases, and the end decision with the conclusion. First, let us see the introduction. A sorting made simple with the heap sort, okay, and sorting algorithms. Sorting algorithms are like recipes for arranging the things in specific order. Just like you sort cards in a deck or arrange books on a shelf, or a computer use sorting algorithms to organize data. Sorting algorithm is nothing but it is a set of instruction in order to perform a task, and it is same like a recipe, that is it gives the steps to perform what is the task, okay. And it is if suppose if you want to prepare a dish, you need recipe, right? The same thing, if you want to perform a task, we need algorithms. And introduction to heap sort. Heap sort is one of these algorithms. It's like a methodical way to arrange the numbers or data. Imagine it as organizing a messy room by putting the biggest things in the right place first, okay. And importance of efficient sorting. Efficient sorting is like having a super fast librarian. It helps the computer find information quickly, which is crucial for tasks like searching, organizing, processing data. That is, with the help of the this heap sort, we can sort the elements very quickly, and it is very efficient, and it's also fast. And let us see the definition of the heap sort. Heap is like a special container for data that arranged in special way. It's like a pile of items where each item has a value, and heap is structured so that most important item is always at the top. That is, suppose if you consider a tree, and if you want to sort the elements, and in that case we will find the first, we will be putting the maximum element at the root, and again we swap the what is it, the top element, that is root element, with the last element. And once we swap it, we delete the leaf element, that is, and we put the what is that leaf element in the array. That's what it said. That's the definition of heap sort. And explanation of the max heap and min heap. That is, we have two types of heap sort, that is max heap and min heap. In the max heap, we will be putting the what is that, the largest element at the root. In the min heap, we put the smallest element at the root. That's what it says. There are two types of heaps. It is a max heap and one is a min heap. And the most item is at the biggest one, that is in the max heap. And the min heap, it is the smallest item, like the youngest in the family of in a family tree. And let us visualize it with the what is that, the help of diagram. As I explained previously, in the max heap we will be having the what is that, the last element at the root, the biggest element at the root. And in the min heap we will be having the smallest element at the root. And the other part, and the next thing is the picture of a binary heap as tree with the branches. Obviously there are branches, and at the top you have the most important item, that is root. And it branches down to other items with the smaller values. And it's like a family tree where the oldest person is at the top, and their children and the grandchildren, okay. That is, we are talking about the max heap. In this lecture also we'll talk about the max heap, not about the min heap. And let us see how it works. Heap sort algorithm. Heap sort is a systematic way of organizing the items, ensuring the most important, that is largest item, is always at the top. That is, we are talking about the max heap here. And first step is EP5. Imagine you have a pile of items. The first step is to turn this pile into max heap. That is, it's like organizing a stack of books, so the largest one is top. That is, EP5 is nothing but we will be finding the largest element in the root, means in the largest element in the tree. And second step is extract. Next you make the most important item, that is largest, from the top of the heap. And it's like grabbing the tallest person from the family. That is, we will be putting the max, that we will be extracting the max element, and we will be re-epify. After taking the biggest item, you need to restore the max heap structure. It's like putting the next tallest person at the top of the family tree and arranging the rest according. That is, we have to repeat the steps in order to sort the elements. And let us see how it works. Okay, with the help of an example, build a complete binary tree from a given array. That is, we will be arranging that is, we will connecting the array. We have the array 4 elements, 4 10 3 5 1, and we will be arranging it in a graph. Arranging it in a tree. Okay. And second step is max cp5 constructed binary tree. That is, uh, we should follow one condition, that is the parent should be greater than the children. So we will be swapping 10 and 4, because 4 is a parent and 10 is a children, and it is not following the condition. Okay, so we will be swapping 10 and 4, and we can see that 4 is what is that, the 4 is parent. Okay, that is less than child. So this, it is against the condition, right? So we should swap the elements. We will be getting 5 as parent and 4 as children. And once we get the what is that, the largest element, that is 10, we will be swapping it with the last element, that is 1. And again we will, what is that, once we swap the elements, we will be putting the 10 what is that, element into the array. And again we will max heapify, that is, we will be heapifying. That is, one is the root, right? And one is not following the condition. That is, one, that is, the parent should be greater than child, but here it is opposite. Okay, so we will be swapping 1 and 5. And in the next step 4, we will be what is that, once we get the max element, right, in the tree, we will be swapping it with the last element. And once we swap it, we will be putting that to the array, that is removing from the tree. And again we have 1 4 3. Okay, since 1 is less than 4, we will be swapping the element, so that it should follow the condition. So we get 4 1 3, that is 4 as parent, and 1 and 3 are left and right child respectively. And once we get, we will be, what is that, we will be remove the max element 3 and insert at last vacant position of the final array, that is arrays 3 4 5 10. And we'll be getting the last element, and we will be putting that to the array. That's how the heap sort works. And we will be getting the final array, that is, we will be getting the sorted array 1 3 4 5 10. And let us see the code. Before entering to the code, I will be telling a few points by considering the previous slides. Okay, here I have given the largest as I and the left and right child. First we should see what is the largest. I will tell with the help of an previous slide, with the help of previous slide. As you can see here, we will consider the index I for the element 10, and index I plus 1 for the 5, and index I plus 2 for 1. Okay, you should consider this, and we will enter the code now. And as I told earlier, you should visualize it in the mind. And once we assign this index to these elements, we will be checking the if condition, that is, if the left child is greater than the largest, we will be assigning the left to the largest, that is, we will be assigning the index to the largest. And if the right child is greater than the, what is that, the largest, we will be assigning the right to the largest. And suppose if the largest is not equal to I, we will be swapping the elements, and we will again epify, that is, we will recursively call the function. And in the next step, we will be building the heap, that is, with the help of for loop. And that for loop will run till I is greater than or equal to 0, and again we will be recursively calling the function. And last step is, we will be extracting the elements from the heap one by one in order to put that to the array. Okay, and let us see the advantage of heap sort, that is stability and efficiency. It keeps the things stable when the values are same, and its efficiency, it's super efficient, especially for large list of data. That is, it can sort very large data sets. Okay, that's the main thing we use the heap sort. And in the use case, priority queues. Imagine you are in a hospital emergency room. Patients are having different levels of urgency, and doctors have to see them in the right order. Heap sort is like organizing the patients based on severity of their condition, ensuring the most critical cases get the immediate attention. Okay, this is one of the use case where it is used in the hospitals, where the severe patient has to be addressed, or he has to be looked after first, right, when compared to other person. Here we use the heap sort. And the data sorting, as I told in the earlier slides, where it is used to sort the very large amount of data sets or data. It can sort very quickly and efficiently, so we use the heap sort. And we come to the conclusion where heap sort is like a reliable friend for sorting the data efficiently and stably, and it's known for its speed with a time complexity of big of n log n. And heap sort is space efficient, using only a limited amount of extra space. Okay, and if you have any doubts, you can write the comments in the comment box. Feel free to ask the questions, I will be there to assist you. And if you enjoy the session, please do like, share and subscribe. Thank you.